Hello students, we have here an example of table again for normalization. So in this example, we want to normalize the given table to 1NF, 2NF, and 3NF. So show the primary keys and foreign keys also. For this example, we can use the relational schema to normalize the process. So instead of copying the records, we can only write the table names and its attributes. So let's have an example. So we have here the columns student ID, student name, student age. Then we have the course code, course name, lecturer ID, lecturer name, and marks. So here we can see we have information about the students, information about the course, information about the lecturer. And for the marks, so we need the information, the attribute student ID and course code to determine the marks of the student. So for example, for student ID 101 Abdullah, for Fundamentals of Computing and Information System course, his mark is 75. For same student, for CSDB 1102, his mark is 85. So meaning, for our table, the full dependency is the student ID. So we need the student ID and course code to determine the marks of the students. So we can identify our dependencies in this example. So let's see this one. Okay, example for our dependency. So let's take a screenshot so that we can draw our dependency table. So we cannot simply draw here in, let's try. Let's try using the draw. Okay, so let's identify our primary key, foreign key, as well as the dependencies of our table. So let me use the blue one. So in our example, again, the course code, student ID determines the marks of the student. So that will be our full dependency. So let's do it here. Student ID, course code determines the marks. So we have here our line, okay, going out, then going here in our marks. So let's see. Marks. So this will be our FD or full dependency. So the next one, we have to look for our partial dependency. So let's look for dependency in our table. Again, dependency, the attribute determines another attribute. So for students, just like for students, if I know your student ID, I can determine your name or your age. So like this. So in this example, we have student ID, which determines the student name. So if I know the student ID, I can determine the student name as well as the age of the students. So this is called partial dependency because there's a dependency on the part of the primary key, which is the student ID, which is part of the composite primary key, and there's a dependency on it. So that's called partial dependency. So we write here PD. Okay, so PD. Okay, PD, partial dependency. So another dependency we can see here, we have the course code. Okay, course code determines the course name. So if the course is CSDB 1102, then that is Introduction to Database. If CSCM 1101, this is the Fundamentals of Computing and Information System. So as you can see here, so there's dependency on the course code, okay, for course name, okay, as well as lecturer ID, okay, and the lecturer name. So this is part of the partial dependency. So we can write here PD, so partial dependency. Okay. So the next one is our transitive dependency. So for our transitive dependency, there's a key, there's a dependency on the non-key attribute. So we can see here the lecturer ID. So if lecturer ID is 60, it is Fatima. Okay, Fatima here, 60, Fatima here. Then if it's 65, it's Manad. Then here Manad and also here Manad. So through the lecture ID, we can determine the lecturer name. But take note, lecturer ID is not a primary key in this example. So it is a non-key attribute. So if it's non-key, but there is functional dependency, so it's called transitive dependency. Lecturer ID and lecturer name, or lecturer ID here is not a primary key. We have the composite primary key, student ID, and course code. So these are the composite primary keys that determines the marks of the students. So this is our dependency diagram. So we can use this in normalizing the given table. So as you can see, we have here our repeating group. We have 101 here. Okay, so if we will write Abdullah 18, 101 Abdullah 18. So as you can see here, our row, the free data here, or the null values indicates that these student information are repeated up to the last row here for Hind. So meaning this student Abdullah has 3 courses, Hind has 3 courses, and Yaqub is also having 3 courses. So we have here what we call the repeating group. Okay, so that is our repeating group. So in 1 and F, we have to separate the repeating groups, underline the PK and FK, and name our tables. So we can use the relational schema for this example. So we have the student ID, okay, and then we have the student name in the repeating group. So we have also the student age, okay. So that will be our columns for the repeating group. So we can name our table. So this will be our primary key. Okay, the student ID. So this talks about students. So we can say that the table name that we can use for this is students. So the students has student ID. That determines the name and the student age. Okay. So the next is the other half of the table. So what should we do here? So we have the course code. So we can copy, comma, course name, lecturer ID, lecturer name, and marks. Okay. So we have here lecturer name and then marks. So I just copied the columns course code, course name, lecturer ID, lecturer name, and marks. So we have the other half of the table, but we need the student ID to determine our the owner of the courses. So we have to add the student ID to the second table. So there will be student ID here. Student ID, comma. Okay. So this talks about the students and the courses. So we can name it as stud courses, or meaning student courses. Okay. Now let's underline the primary key. So our primary key is the student ID. Actually, this will be the composite primary key. Then course ID also here. Okay. So this will be our 2 tables for 1 and F. So this is much simple compared to adding the records. So you can use this also in writing your test or exams. Okay, so we are now finished with the 1 and F. Okay, the next one is the 2 and F. So the rule for 2 and F, it must be in 1 and F. So meaning no repeating group. We identify our primary key and foreign keys in the table, and we add names for our table. So we're using the relational schema or just the column names and table names to normalize our table. So with this, we have to study the main table for example records. Okay, now we're done with the 1 and F. Okay, now what we do in the 2 and F, it must be in 1 and F, and we have to separate the partial dependency or full dependency. We have to look for this in our example. So here, since we identified already the partial dependency for the students, so we have it already here. Okay. So, and there's no other dependency. So actually, for the students here in our example, um, it is normalized for these columns because only the student name and student age is dependent on the student ID. So no partial dependency and no transitive dependency. So we can copy now the student table here in our 2NF. Okay. Now let's study the next table. So we have the next table here, or the relation student courses, okay, with this column. So let's identify now the full dependency. So here we can see that there is partial dependency. So where is this partial dependency? Again, going back to the table, we have here the course code that determines the course name, the lecture ID, and the lecturer name. So in my technique, so I normally separate first the full dependency. So again, the full dependency is the student ID, course code that determines the marks. So we get these three columns, the student ID, course code, so copy, and then also the marks. So I'll just put it here. Okay, I'll copy from here. Okay, and lastly, we have the marks. So copy here. Comma, marks. Okay, so that will be our full dependency. So we have to separate it from this table. So this is the one that we are actually dividing. We get student ID, student course, and the marks. So this is the full dependency. We put it in a new table. Okay, how about the remaining? So we get the course code, or this is the partial dependency. As mentioned earlier, course code determines the course name, the lecture ID, and the lecture name. So we put this in another table. So from here up to here, lecture name. So we will not include the marks. Okay, close and then close here. So we can name this as courses since our primary key is course code. Okay, and then there's the dependency on our course code. It determines the course name, lecturer ID, and the lecturer name, ID and name. Okay, so this will be now our 2NF. So whenever you split a table, notice that it can still be connected. So we can still connect the course code and course code here, student ID, and then student ID here. Okay, now in 3NF, the rule is it must be in 2NF, and we have to separate the transitive dependency, copy the normalized table in 2NF without the partial dependency or the full dependency, underline the PKFK, and name and connect our table relations. Okay, so now let's look for the table. So based on the 2NF, let's look for the table with transitive dependency. So let's check the first one. I think there's no transitive dependency. Meaning of transitive dependency is dependency on the non-key attribute. So as you can see in our diagram, the lecture ID determines the lecture name. So this is our transitive dependency. So for this, we just have to copy the student ID, the student's table, and then the student courses. So we don't have the transitive dependencies on these tables. Now, let's take a look on courses. Okay, so we have the lecture ID, okay, determines the lecture name. So this is the transitive dependency. So you can make a new table, paste it here. So it's about the lecturer. So we will name it as lecturer. Okay, so normally tables have letter S because it gives us it tells us that there's not only one lecturer but many lecturers. Okay, so now we cut this in half, so we get the lecturer ID, lecture name. So what about the course code and course name? So we will put that in a new table, but we have to include the lecturer ID that will connect the two tables again. So we cannot leave the lecturer ID alone. Why? When you split the two table, okay, copy here. Okay, we split these two, but there's no way for us to connect. So what will happen is that there's no connection. So remember, they belong to one table originally, and now you split it. So there should be a way for you to connect it. So do not forget When you transfer the lecture ID, lecturer name in a new table, the remaining part still you have to copy the lecturer ID. Okay, so here is the example. And lecturer ID here will serve as our, ah, wait, lecturer ID, course code, course name. Okay, because we copied earlier. So course code, course name, and then this one, lecture ID will serve as the foreign key. So we put here dash line. Okay, so now let's check. There's no repeating group. All are in the students table, all are dependent on the student ID alone. Student ID determines the student name, student age. Then we have here our full dependency, the student's courses. Together with the student ID and course code, we can determine the mark. So we have our full dependency on a separate table. Then we have the lecturers, which is the, here we have the primary key. Okay, okay, it should be a straight line. Okay, okay. Lecturer ID determines the lecturer name. And lastly, we have courses. Course code determines the course name and the lecturer ID. So we can connect the lecturer ID in the lecturer ID here. Student ID, then course code to course code. So even if you split the tables into 3 or 4, you can still connect them. So you can still get the information from other tables. Okay, if you want to get the course of this student, you can connect to this course and get the marks and also identify the course name through the join with the courses table, and get also the teacher based on the lecturer table. So this will be the final answer. Okay, so in 1NF we have 2 relations or tables. Then we have 3 tables in the 2NF, and then 4 tables in the 3NF. Okay, so these are the steps you have to follow. The most important thing is you know where to divide your table. So the technique is find the repeating group, and that is the half of the table. So first half goes here on the first, second half goes on the next. So that's the first thing that you need to identify. Where's the half of the table, and identify the repeating group. So once there, you can do now the 2NF and then the 3NF. So take note, when you do the 1NF, again, when you divide the table, you have to take the student ID or the first column here in the second table. So we have the student ID added in our other half of the table. Okay? Then, also here, we remove the partial or the full dependency. So this is the full dependency based on our diagram. Then, also for courses, so this will be our separate table. So when you get the table from here, okay, so when you divide it in half, or you get the full dependency, then the remaining will be course name, lecture ID, lecture name, but don't forget the course code. So it will be part here. And then 3NF, we remove the transitive dependency, so that will be for the lecturer ID. So based on 2NF, okay, here we have lecturer ID, lecturer name. So you use the previous phase when dividing your table. So lecturer ID, lecturer name here, and then the other half will be course code, course name, and lecturer ID. Okay, identify your primary key, foreign key, and connect your table. So there we can connect them. So if we will just split it here, okay, and then I draw. Okay, so student ID is connected to the student ID. This is like a relational schema. Course code connected to the course code, and lecturer ID connected to the lecturer ID. Okay, so that's it for this example, using or normalizing our table using the relational schema. So this is shorter and easier way for you to do the normalization. So you can opt this for your test or assessments. Final answer here. Okay, so that's it for today. Thank you.